Hello, pre-calculus students, and welcome to the continuing lesson on behaviors and graphs of higher order polynomials. And what we want to achieve here is to be able to predict the behavior and draw graphs of higher order polynomials. Now, I know that many of you are probably thinking you can probably just graph this and get the same thing, but graphs can be very deceiving and they can be very time consuming if you do not know some of the basic ideas and concepts and some of the basic characteristics of a graph. So we need to be able to analyze graphs, analyze functions both graphically and algebraically. So let's start with the first key concept here. The leading term can tell us the end behavior and a rough sketch of the graph. Okay? So the leading term, let's say this is our leading term, and I'm assuming you know what leading term means and you have a firm understanding of that. If you do not, please look at one of the previous videos or ask your teacher for help. And so if n is even, in other words, if the power here is even, and a is greater than 0, in other words, a is positive, then you're going to get a graph that looks roughly like this. Now, it's not gonna be perfect. It's gonna do some weird stuff in here, but basically it's gonna make some sort of a W-shaped or U-shaped graph. There's gonna be all these bumps and grooves in here, and we'll deal with that in a minute. But if we know that n is even and a is positive, then it's going to look like that. So what we can say then about the end behavior is that the limit of f of x as x approaches infinity is equal to infinity, and the limit of f of x as x approaches negative infinity is also equal to infinity. Okay? In other words, as you go further to the right, the graph goes further up. If you go further and further to the left, the graph also goes further up. Next, what happens if n is even and a is negative? Well, if you understand transformations, it's just a reflection over the x-axis. So it will be a very similar picture. You're going to have that sort of W shape, but everything is going to be flipped upside down. So you're going to have some weird stuff going on in here, and we'll deal with all those details soon enough, but that's roughly the picture of what it's going to look like. And we can say that the limit of f of x as x approaches infinity is equal to negative infinity. In other words, as x gets bigger, y goes towards negative infinity, and the limit of f of x as x approaches negative infinity is also equal to negative infinity. Okay. So that describes what happens if it's going to be, if the degree, okay, this is the leading term, so n is the degree here. I just want to be very clear. This is the degree of the polynomial. All right, well, next, let's look at what happens when n is when you have an odd degree. So the graph, and a good example for this is if you look at the graph of f of x equals x to the third. It'll kind of illustrate what that looks like. And it's going to start down here somewhere. It's going to go up. It's going to do some stuff in between there, but then it's going to keep on going up. So in this case, we can say that the limit of f of x as x approaches infinity is equal to infinity. In other words, as x gets bigger, the whole thing just goes up forever. And then the limit of f of x as x approaches negative infinity is going to be negative infinity. Okay. So as you go towards the left, you go down. As you go towards the right, you go up. Now, and again, in that same scenario, if n is odd and the leading term or leading coefficient is negative, well, it's just a reflection of this. So it's, if you had this graph and everything is flipped upside down, so it's going to start up here, it's going to go do some weird stuff, and then it's going to go down. So now you have the limit of f of x as x approaches infinity is equal to negative infinity, and the limit of f of x as x approaches negative infinity is actually going to be positive infinity. In other words, as you go further to the right, you go down. As you go further to the left, you actually go up. Okay? And so this very basic fact here tells us a lot about what the function does at the extreme values. As x gets huge in the positive directions, as x gets huge in the negative directions, we can kind of predict roughly what it's going to look like. And again, we have these bumps and grooves here that I've talked about, but the main idea is that we kind of know the big picture. In the next video, we're going to explore what happens to the intermediate parts right here. So thank you for watching. Have a wonderful day.